Okay, so for these problems, I ask you for the find the values of x for which the problem is continuous. I am going to also ask you to write it in interval notation. So even though the directions here don't say that, on your quizzes, you will be writing it in interval notation. Okay, so for the first one, where is this one continuous? What I notice about this first one is it's a polynomial. A polynomial is continuous everywhere. So your answer is just everywhere. And the way that we write that in interval notation is we say negative infinity to infinity. The second one is a rational function. That means it's a fraction. So the way that you work this one is you take your denominator, only your denominator, and you set it equal to 0, and then we exclude. So the way I factor this x squared equation is the way I solve it rather is to factor it. The factors of 2 that add to give me 3 are 2 and 1. They are the same sign, both negative. So I'll set the first one equal to 0, the second one equal to 0. Solve those out. Now remember, these are the bad guys. These are the ones we have to exclude. That means all numbers in the whole wide world work except for these two. But you have to be really careful because the interval notation is a little tricky. So if we put these on a number line, dividing the number line into intervals, they're actually 3 pieces. So here's 1 on a number line, and here's 2 on a number line. I know these are bad. These have to be thrown out. So that means all of these numbers over here are good, all the ones in the middle are good, and all the ones on the right are good. Remember, your rule is you will use parentheses anytime it comes from the denominator. Use parentheses. So you can kind of think of it like this: parentheses here, and here, and here, and here. So when you write it, it would go from negative infinity to 1, parentheses. In the middle, it would go from 1 to 2, all in parentheses. And on the right, it would go from 2 to infinity, all in parentheses. And we write a U in between it to represent the union. And that's how that one would look. Unfortunately, it won't fit my little blank at the top, so that's your answer. Okay, moving to the next one, you see the cubed root of 3x minus 12. In the next one, you see the square root of 3x minus 48 plus 3x. Well, these are both radical equations. Radical functions. What's important about these is one is odd and one is even. So the odd one has a cubed root. Okay, see that 3 right there? That's an odd root. That means your domain is all real numbers. That means your function would be all real numbers. You don't have to do any work with a cubed root. The square root you do, though. You'll say, well, what about the 3x on the back? Okay, the 3x on the back doesn't have anything to do. That's just regular polynomial. You don't have to worry about the domain for that part. You only have to worry about the domain that's underneath, the function that's underneath the radical. So remember your notes that I gave you earlier says for an even radical, you take the radicand, that's what's inside, and you set it greater than or equal to 0. So 3x minus 48 is greater than or equal to 0. So 3x would be greater than or equal to 48 when you move the 48 over. Divide by 3, and x is greater than or equal to 16. In interval notation, you would start at 16 and go that way. 16 would take a bracket. Now, you'll say, well, that's pretty easy, but in a multiple choice setting for my online students, if you have multiple choice, remember you have to take the bracket here because it's greater than or equal to. So your answer for this one would just be 16 to infinity. Now let me address the 3x at the end just one more time. If you look at this particular function, remember you only take the radicand and set it greater than or equal to 0. So since the 3x is not underneath the radical, you don't have to worry with that piece. Okay, the last one that you have in this section are the piecewise functions. So it's really easy to do. What you're going to do is evaluate the limit at the split, or at the splitting point of the function. So in this first one, I'm going to evaluate the limit at 0 because that's where my split is. Evaluate at 0. Okay, so what that means I'm going to do is plug in 0 to the top and bottom. Okay, if I plug in 0 in the top, I get 0 plus 1. So I get 1. If I plug in the bottom, I get 0 squared plus 1. So your question is, do they meet? Okay, they meet. Now go back to my discussion of continuity at the beginning. I said, are there any holes in the graph? You are discontinuous where there is a hole in the graph. What you notice about this one is that they meet. At 0, you're going to have the point 0, 1. They meet, so that means there is not a hole in the graph. Since there's not a hole at 0, that means there's not a hole anywhere. And not a hole anywhere would mean that all numbers work. So that's how that one would look. Now, of course, the other one is going to be the second case. So what we're going to do is plug in 4 in the top. And plug in 4 to the bottom. And we look to see, do they meet? You'll say, where'd you get the 4? That's your split point. They're splitting at 4. That's why I'm plugging in 4. If you plug in 4 in the top, you get 4 minus 4, so you get 0. If you plug in 4 in the bottom, you get 4 plus 3, so you get 7. Do they meet? No. Okay, so that means you're going to have a hole in the graph. Writing your answer is the tricky part. So I know that these graphs do not meet when x is 4. Okay, so 4 is the problem. Not 0, not 7. They don't meet when x is 4. So since they don't meet at 4, so that means that 4 has to be thrown out. So the way that you throw 4 out, let me put it on a number line real fast. So if they work for all numbers except for 4, here's 4. Oops. Let me see if I can clean that up just a little where you can read it. There we go. That means they'll work for all of these numbers, and they'll work for all of these numbers. They just don't work at 4. So your answer would be negative infinity to 4, union 4 to infinity. Okay, and that's how it would look. Okay, so in a piecewise function, you're going to have 2 options. Just going back over it one time, looking at the blue function for a second, it's either going to be continuous everywhere, or it's going to be continuous everywhere but 0. Okay, so these piecewise functions have 2 different possibilities. They're either continuous everywhere, or they're continuous everywhere but the split. So in this first one here, the blue one, this one was continuous everywhere. Okay, so looking at the green one, we have 2 choices for this one. It's either continuous everywhere, or it's continuous everywhere but the split. So the split of this one did not meet. So since it did not meet, we had to throw out 4, and that means it was continuous everywhere but 4, and the way that we write that is like you see in the red.